All right, let's get started. Welcome everyone to our webinar today. My name is Justin D'Souza. I'm a quantitative and specialist and statistician here at Statistics Solutions. Today we will be discussing how to conduct and interpret correlation tests. So what I'll do is I'll go through the entire presentation first, and if we have questions at the end, I will review those. I have my colleague Isaides today who will be assisting with questions. So if you have any questions during the webinar, please type those into the chat box or the question and answer box. And if we have time at the end, I will cycle back through those questions. All right. Today, we will start out by talking about the services that Statistics Solutions provides. Then we will dive into the topic and discuss how to select and interpret correlational analyses. I will provide a demonstration in SPSS for conducting correlations and interpreting the findings. And we will conclude with a summary. So Statistics Solutions provides assistance with every part of the dissertation process. We also assist with master's thesis documents. So starting with topic development, can help frame your study. So if you're stuck at the very beginning, but you have an idea, we can help you frame your research questions, the purpose of your study, help identify a problem statement for your study. The way our company works is we will assign a methodologist to you, and we will assign a literature review specialist. Depending on if you're doing a quantitative or qualitative study, we have both quantitative and qualitative specialists at our company that can help identify your research questions and help frame your study for you. Okay, so we assist with the prospectus and concept papers, depending on what university you go to. We help with the proposal chapters, which typically consists of the introduction, literature review, and methodology. We help with IRB forms, data entry templates, uploading your survey into SurveyMonkey. We assist with both quantitative and qualitative results chapters. We have our own company software called Intellective Statistics, which can help crunch your numbers for you and provide an APA write-up if you're doing a quantitative study. And to cap things off, we help with the discussion chapter, PowerPoint for defense. And once your paper is approved through your university, maybe you're interested in a journal publication at some point. We can help you condense your dissertation and put it into a journal publication. So if you've hit a roadblock, please give us a call at 727-442-4290. For today's topic, we're going to discuss how to conduct correlational analyses. So before we get to that topic, we need to lay the groundwork. Most statistics fall into two branches. You have both parametric and non-parametric techniques. Parametric statistics are typically based on assumptions about your population from which your sample is derived. So usually this assumption is that your data follows a normal distribution, or it's following a bell-shaped curve. And typically you run parametric techniques or analyses when you're looking at continuous variables. The opposite side of that spectrum are non-parametric techniques. Non-parametric statistics are not heavily based on strict assumptions, meaning that you don't necessarily need to have a normal distribution when running non-parametric techniques. So diving a little bit more into parametric statistics, you need to have a normal distribution, meaning your data needs to follow a bell-shaped curve. And there are various ways to test for normality. If you read one reference, another reference is going to give you an alternative option for testing for normality. So you'll have to figure out what is best for your school. What is your school looking for? So you can use a Shapiro-Wilk test, a Kolmogorov-Smirnov test. You can look at the skewness and kurtosis values, and you can look visually at scatter plots and histograms. Typically, if the data does not follow a normal distribution, you need to find a non-parametric alternative to running your statistics. Something to keep in mind, though, is if you have a large sample size, greater than 50 cases, you can use what's called the central limit theorem to justify using parametric statistics, even if your assumption of normality is violated. So maybe you run a Shapiro-Wilk test or a Kolmogorov-Smirnov test, or you look at your histogram and it's heavily skewed. It's not following a bell-shaped curve. That isn't heavily problematic when you have a large sample size. So I provided a citation here. Howell 2013 states that violations of normality are not problematic when the sample size for the research exceeds 50 cases. Here we have the reference. So now we can look at what types of levels of measurement we have in statistics. And depending on what level of measurement you're using, that will pinpoint to a specific statistical analysis. We have continuous variables. Continuous variables are variables that fall on a continuum. Some examples of this are test scores that are maybe from 1 to 100, SAT scores or ACT scores, temperature, weight, measured in pounds or kilograms, and composite scores that are computed from a previously validated instrument. Maybe you have a Likert scaled instrument that's ranged from 1 to 5 measured. Let's look at an example like job satisfaction. It has 10 items, the JSS, and it ranges from 1 to 5. If you take an average of those 5 to 10 items, that new variable is going to be continuous because you can have decimals as possibilities for job satisfaction collectively. So that is now a continuous variable. Nominal variables are categorical variables. So these are variables that don't have an intrinsic order, such as gender, ethnicity, or passing and failing of an exam. Each group can be independent of one another, and it's not ranked or ordered. This is a nominal variable. An ordinal variable is a subset of a nominal variable, but the possibilities in an ordinal variable are ranked or ordered. So something like education, you go from high school, college, master's, doctorate. There's a natural progression. That is an ordinal variable. And individual items on a Likert scaled type survey. The individual item is ordinal because you have discrete categories, but it is following a ranking. That would be an ordinal example. So we have continuous, nominal, and ordinal. And from here, we have 4 different types of correlations we can run. So under the parametric technique family, you can run a Pearson correlation, tests for the association between 2 continuous variables. So 2 numeric variables. So maybe test scores, and if you're comparing SAT scores to GPA or SAT scores to ACT scores, that would require a Pearson correlation. A point-Biserial correlation is also under the parametric technique family because you need a continuous variable, but you also need a dichotomous variable. So a dichotomous variable is something that has 2 possibilities, kind of like gender, male, female, or passing and failing of an exam. If you have 2 discrete categories, then you can do a point-Biserial correlation. A Spearman correlation is now under the non-parametric technique family. A Spearman correlation tests the association between 2 variables when at least one is measured on an ordinal scale. So if you had a continuous variable and an ordinal variable, you would run a Spearman correlation. If you have two ordinal variables, then you would run a Spearman correlation. And the final example we have here is a chi-square test of independence. So this is used when you're testing the association between two nominal or categorical variables. Okay, so something like, is there an association between gender and ethnicity? That would be a chi-square example. Okay, so when you examine the first three types here, Pearson, Point-Biserial, and Spearman, this is the process you want to follow. So you want to examine the p-value to tell you if you have a significant relationship between the variables of interest. And typically in the social sciences, we use a p-value below 0.05 to indicate that you have a significant relationship. And you want to apply Cohen's standard to interpret the strength of your correlation coefficients. So we have Pearson correlations, Point-Biserial, and Spearman here. You can use Cohen's standard, which is in this next bullet point, to interpret how strong of a relationship do you have. So according to Cohen, he says that correlation coefficients between 0.1 and 0.29 represent a small association. Coefficients between 0.3 and 0.49 represent a medium association, and coefficients above 0.5 represent a large association or relationship. And we have the citation and reference at the bottom here. So now we'll jump into a Pearson correlation. So again, a Pearson correlation is a parametric technique that tests the relationship between two continuous variables. What do you want to do first? You first typically want to check for normality. Okay, so you want to check for normality. Again, if you're going to a university, they might have their own guidelines on the best way to check for normality. There are several ways to do it. If normality is not supported, then you would want to consider using a Spearman correlation as an alternative. So remember, a Spearman correlation is the non-parametric alternative to a Pearson correlation. So a Spearman can be used when you have ordinal variables, but it can also be used when you have non-normal variables, meaning they don't follow a bell-shaped curve. But keep in mind that if you have a large sample size, as we indicated before, you can apply the central limit theorem to proceed with using a Pearson correlation, because violations of normality are not really problematic when you have a large sample. And then you can use that citation that I provided over here. So large samples greater than 50, violations of normality are not problematic. Okay, so let's look at an example of a Pearson correlation in SPSS. So I have a data set over here, which I will put on the screen. So in this data set, we have different car models, Honda Civic, Toyota Corolla, and we have various measurements for each of these car models. We have the weight, we have the miles per gallon, we have horsepower. Now, when I come into SPSS, anything that is numeric like this and has a decimal possibility is continuous. So these are considered two continuous variables. Now, say we wanted to test the relationship between the weight of a car model and how many miles per gallon it obtains. We would do a Pearson correlation here between these two variables because they are both continuous. They both are scale variables. So to do this, we are going to go to Analyze and Correlate and Bivariate. Okay, and even before I do that, let me show you how to test for normality. So we want to test for normality on these two variables before running that correlation. Many ways to do that in SPSS. One way is to go to Analyze and Descriptive Statistics and Explore. right here. So this box comes up now, and we need to test for normality on weight and miles per gallon. So I'm moving those two into the dependent box list. And then I'm going to click plots. And you'll see this option comes up. We want to check mark normality plots with tests. Okay, so we'll click continue and OK. And this is what comes up. We just scroll down a little bit and you'll see tests of normality right here. And we have a Kolmogorov-Smirnov test and Shapiro-Wilk. These are the two most common procedures I see for testing for normality. I mean, you can use histograms and PP plots and scatter plots, but there's nothing really better than having a number tell you definitively, do I have a normal distribution or not? And this is what Kolmogorov-Smirnov and Shapiro-Wilk tell you. So when you interpret these, this is a rare time in statistics where non-significance is what you're shooting for. A significant result is actually a bad thing in this case. So what it's doing is it's comparing your data for weight and miles per gallon to a bell-shaped curve. And if the results are significant, that means your data is significantly different than a bell-shaped curve, which is not what we want. So ideally, we want p-values greater than 0.05. So the significance column, these are the p-values for the tests. And we want these to be greater than 0.05, meaning they are non-significant. So that is the case here. We have for weight, 0.142, 0.093, those are both greater than 0.05, and then 0.200, 0.123, those are both greater than 0.05. So normality is supported for weight and miles per gallon. This gives us the green light to proceed with the Pearson correlation. So I will go to analyze, correlate, bivariate, and let's put in our variables. You can see at the bottom, we have three options. We have Pearson, Kendall's tau, and Spearman. Let's put in weight and miles per gallon. So we can see that here. Then we click OK. So here is our Pearson correlation. And we can see the relationship between weight and miles per gallon is significant. That's great. Our p-value is less than 0.001, which is less than 0.05. So it's actually very significant. And then you can interpret your correlation coefficient, which is right here. So our correlation coefficient is 0.868, negative 0.868. So remember, coming back to the presentation here, I have a slide about Cohen's standard right here. So Cohen's standard, and you want to take that 0.868 and compare it to Cohen's standard. So 0.868 falls in this threshold here. So this is above 0.5, meaning that the relationship between weight and miles per gallon is strong. Now it's a negative correlation, so that means as one variable is increasing, the other is decreasing. So as weight is increasing in value, miles per gallon is decreasing, and the vice versa to that statement is true as well. So as miles per gallon increases, weight is decreasing. So you could visually look at that relationship in a scatter plot. So I'll go to graphs and chart builder. And we come up with this window. We want to do a scatter plot. And we'll put weight on the x-axis and miles per gallon on the y-axis. Okay. And clearly we can see that there's a negative trend here. You can almost draw a line going from the top left to the bottom right. So as weight is increasing, miles per gallon is decreasing, which makes completely intuitive sense. Okay, so that's a Pearson correlation. Now we can take a look at a Point-Biserial correlation. So a point-biserial correlation is also a parametric technique. However, in this case, instead of two continuous variables, you have a continuous variable and a dichotomous variable. So a variable with two possibilities. Due to having a continuous variable, you'll want to check for normality again. So it's a similar verification as we did previously. Normality is not supported, then you might want to consider using what's called a Mann-Whitney U-test. So this is a non-parametric technique that's used more for differences as opposed to relationships, but you can test for differences in your variable between your two groups. Okay, so let's take a look at a point-biserial example. So what if we wanted to see the relationship between transmission type? There's only two possibilities here, automatic and manual. How does that relate to the weight in a car or the miles per gallon? We would do a point-biserial correlation here because we have continuous variables and we have a dichotomous variable. So let's go to analyze. We'll go to correlate. And this one's easy because the math is actually very similar for a point-biserial correlation as it is for a Pearson. So they don't even have the option in SPSS for point-biserial. You just check mark point or you check mark Pearson. It's going to give you the same result. Okay, so we'll put in transmission type. Let's do miles per gallon. Click OK. So we can see here, again, we have a significant relationship. Our p-value is below 0.05. It's actually below 0.001, so very significant. And we have a, let's see how I coded it. So automatic is 1 and manual 0. So this means that automatic cars, in this example, had lower miles per gallon in comparison to manual. Okay, so for this, we could also do I would say probably a bar chart for this one. Let's try that. So if we do transmission type and miles per gallon, see if this works. Okay, so we can see here 0 in this case was manual. Okay, so manual had better mileage in comparison to automatic. That's what this is showing. And again, when you look at that correlation value, this was 0.6. You want to compare that to Cohen's standard. So Cohen said anything greater than a 0.5 is a strong relationship. So that is what we have here as well. Okay, our next correlation type is a Spearman correlation. This is used when you have a relationship between two variables when at least one is measured on an ordinal or ranked level. So there are not strict assumptions to check for a Spearman correlation because the data is non-parametric. Okay. However, if you propose to use a Pearson correlation initially and normality is not supported and you have a small sample size, you might want to use a Spearman correlation as a backup or an alternative. As an example here, we can do a Spearman correlation between, did have a variable in here, so horsepower. You can see we have 2 horsepowers. I had to make a variable here. So say instead of giving you the actual horsepower right here, we have it in the actual count. It was instead given to you as levels like 50 to 90, 50 to 99, 100 to 149. I coded it here so we can see the different levels. This is an ordinal variable because we don't see the specific horsepower, but we see it in a range. So 50 to 99, 100 to 149, and so forth. This would be a good example of a Spearman correlation because we have a ordinal variable and say we want to test how does horsepower relate to miles per gallon. Okay, so we'll go to analyze, correlate, bivariate. Take these two out and add horsepower and miles per gallon. Now, before running it, you have to double check what is being conducted here. We are going to run a Spearman, not a Pearson. Spearman because it's ranked. Click OK. And again, we can see a very strong relationship here. So there's a negative association. It is significant. This 0.9 is greater than 0.5. So it's a strong relationship. And the negative indicates an inverse association. As one variable increases, the other variable is decreasing. So the higher horsepower is associated with lower miles per gallon, or higher miles per gallon is associated with lower horsepower. The statement works both ways. Okay, our final examination here is called a chi-square test of independence. So a chi-square is used when you're looking at the relationship between two nominal or categorical variables. So we do have a couple categorical variables here. We have engine type, whether the engine was straight or V-shaped, and we have transmission type, whether you have an automatic or manual car. So let's see if there's an association between those two. A chi-square is in a different option here. It's not going to be under correlate. We're going to go to descriptive statistics, then select crosstabs, which means cross tabulation. And I've actually already put it in, but we'll do it from scratch. So we have engine type as one variable and transmission type as our second variable. Before you run it, you'll want to go to statistics, click that option, and check mark chi-square. That is going to give you the chi-square coefficient and p-value. We'll click continue and OK. So a chi-square test is going to give you a cross tabulation between engine and transmission type. You can see how many straight shaped engines were automatic. We had 7 straight shaped that were automatic and 7 that were manual. We had 12 V-shaped that were automatic and 6 that were manual. Then you look down at this Pearson chi-square test, and we can see that the p-value is greater than 0.05. So in this case, we have a non-significant relationship, meaning that engine type is not strongly correlated with transmission type. All right, so as a summary, you want to first identify what is the level of measurement for your variables. And ideally, you have the research questions set in stone, you're in the methodology. So once you know the level of measurement, you can figure out what type of correlation is best. Now, we focused on correlations today. There are many other types of tests, and we've done webinars on them. We've done a test of differences webinar, and you can see the link to that. We will provide a link for you to view the past webinars. But in that one, I talk about ANOVA's t-tests, Mann-Whitney U-tests, things like that. And then once you've figured out what test you're going to run, you want to check for assumptions if you're running a parametric technique. And if normality is not supported, or you have a small sample size, then you might want to run a non-parametric technique instead. Well, thank you for joining us. Just to reiterate, Statistics Solutions is a full-service dissertation company. We assist with all portions of the dissertation. We assign a methodologist to you, and we assign a literature review specialist, and they can help address feedback and provide guidance to help you get through the process. If you have any questions or would like to schedule with us, you can email at info@statisticsolutions.com or give us a call at 727-442-4290. We'll now open up the panel for questions. And by the way, we are going to send this PowerPoint to everyone that joined. All right, so let's see. I do see some questions in a couple places, so I'll look at the question and answer portion first. So Larry asked, how would you test the correlation between an ordinal variable and a nominal variable? Most likely, you would use a chi-square test. You could use a chi-square. If you don't have a ton of categories, I would do a chi-square, which is the last thing I showed here. So an ordinal variable like education and a nominal variable like gender. You can do a chi-square test of independence for that. And a continuous variable, how do you test a continuous variable and a nominal variable with more than two categories? So this is going into a different type of analysis. So most likely it would be something like, are there differences in, say, job satisfaction based on ethnicity? So job satisfaction might be a continuous variable. Ethnicity is a nominal with more than two categories. You would probably use an analysis of variance for that. So an analysis of variance will tell you, is there a difference in your continuous variable between the multiple categories? Let me know if that answers your question, okay? And I'll now move to the chat box. We have a question from Charles. How does one refer to variables since there is not an IB or DB? I also do not have a predictor or criterion since this is nothing causal or predictive. That's a great question. Typically, when you are doing correlations, you don't have an independent or dependent variable. What you have are just called variables of interest. So you don't have a prediction going on. There's nothing causal, as you said. You just have two variables of interest, and it's not an independent or dependent variable. So it's a two-way relationship. Teresa asks, would you also run a Spearman correlation when you fail to meet the assumptions of a Pearson correlation? The main one is normality. If normality is not supported, then you probably want to run a Spearman correlation as a backup. I did discuss how if you have a large sample size, you can make the argument to proceed with running a Pearson correlation. You mentioned if outliers exist. I haven't seen that really affect what analysis is run. I would consider removing the outliers and then sticking with the Pearson correlation. Hi, Sonia, I see your question. Could you briefly explain what is Kendall's correlation for? So Kendall's tau is, I rarely see it used today. I think the Spearman correlation has taken precedence nowadays, but a Kendall's tau is very similar to a Spearman's correlation in that they're both non-parametric techniques. Kendall's tau is giving you a non-linear association. So if you don't hypothesize that there's a linear association between your variables, which a Pearson and Spearman do, then you might want to go with a Kendall's tau instead. Looks like we have a question from Teresa. My sample size is 145. So because it's not small, does that mean I can't use a Spearman correlation if I don't meet all the assumptions of a Pearson correlation? 145 is a great sample size for Pearson, Spearman, Point-Biserial. Every test I ran over today, you're going to have a large enough sample for that. So I would say if you have two continuous variables, proceed with your Pearson correlation. Test for assumptions. If normality is not met, then potentially run the Spearman correlation as a backup. Stick with the Pearson, but present the Spearman as well, just to say you ran it as a backup due to non-normality. But you have an argument for sticking with your Pearson correlation because your sample size is 145. So that's a really good sample size for correlations. Hi, Teresa. My name is Justin. Okay. Teresa asked if we can get one-on-one assistance. Yes, you can contact us. I do have the final slide open here. So you can email us at info@statisticsolutions.com or give us a call at the number listed, and you can schedule a call with our consultation department and let them know where you need assistance, and they will assign a statistician to you. You have a question? Mary, my sample size may be 1,000, so no worries with parametric. Absolutely. You're in great shape to run parametric analyses. Just be cautious that with such a large sample size, you could see significance everywhere, even if there's not a really strong effect. When you approach the thousands, you're going to see significance quite a lot. So just keep that in mind. Do you lose power if you use a chi-square test with ordinal data? Seems that we are throwing information out. I don't think so. No, I mean, ordinal data is a subset of the nominal data. So I don't see a problem doing, I see chi-squares done all the time with two ordinal variables or an ordinal variable and a nominal variable. It's actually useful because you'll see how many people fall into each group between the two variables. So no, I don't think you lose power. Teresa asked, can outliers be replaced by the mean? Yes, they can. That's called mean imputation, where you replace the missing cases with the average of that variable. And I think I answered the two questions from Larry about testing a ordinal and nominal variable. That would be a chi-square. Larry, you could also look at a Kruskal-Wallis test. That could be an option for you as well. So that would tell you, are there differences in your ordinal variable between a nominal variable? So it's getting a little away from correlation, but it's going to tell you, are there differences? That's the key word there. So Teresa, you were asking about imputation. Yeah, I can show you real quick. Give me a second. So in this spreadsheet here, say I had blanks, right? Under horsepower, what I would do is run descriptive statistics under horsepower. So analyze descriptive statistics. And let's put horsepower in there. So we can see that the average is 145.38. So if I sort this ascending, I have all the blanks right here. So 145.38 would go in these three boxes. That's mean imputation. Replacing the missing values with the average of the variable. Yeah, Charles, we did cover ANOVAs in a previous webinar. This one's focusing on correlations. So you can, ISATES did put the link to previous webinars, and you can check out our tests of differences webinar. And you asked, do I have a continuous variable and a categorical variable? Yep, that's right. I think an ANOVA is best for you in that case. And Teresa, if you do this, are you still meeting the assumption of the Pearson correlation? Yeah, I mean, that replacing missing data has nothing to do with the assumptions of a Pearson correlation. Maybe it's an outlier. If you have outliers, you want to remove the entire case from your study and then run the data without those people in it. But missing data is not really one of the assumptions of a Pearson correlation. If you have missing data and you run a correlation in SPSS, it's automatically going to exclude those people. Thanks, Isades, for sending the link. All right, do we have any additional questions? You can type them into the chat box or the question box. Yes, we do work with students. Yeah, absolutely. So when you call or email at the links provided, you will speak with Janine, and she will guide you in the right direction. And you can request to work with me, absolutely. Sure thing. All right, do we have any additional questions? We'll stay on for a few more minutes. When will the PowerPoint be available? Isades can answer that question.
Good evening, guys. So every registrant is going to receive an email with a link to the PowerPoint recording and also a link to download the presentation slides. You'll receive that email tomorrow. You can expect it around the same time as today's presentation at 5:30 p.m. Eastern Time.
All right, sounds good. Thank you, Isades. Thanks for joining, everyone. All right, I'll stay on for a couple more minutes. Do we have any last minute questions? Isades said she's going to send the PowerPoint tomorrow. It'll be around the same time as today. Yep, and please register for the upcoming webinars. I'll be doing another one on Tuesday. Yep, thanks for joining, Lisa. Teresa, I think Isades put the link just a couple questions before your question there. There you go. There it is again. All right, sounds good. Have a good evening, everyone, and come join us again. Have a good evening. Bye.